Hello, welcome back. Now we are programming a divider in the Max 10 FPGA University program. So the goal of this project is to design and implement a 4-bit divider using a successive subtraction of the FPGA. This is a 4-bit divider in a digital circuit to perform a binary division effectively and repetitively subtraction values. The project will utilize the Intel Max 10 FPGA to manage the complex logic operations involved in a divider design, demonstrating its capability in high-speed arithmetic computations. So now the development. So this VHDL code defines a digital circuit for a 4-bit divider using successive subtraction. The design is encapsulated by an entity named divider here, which accepts two 4-bit inputs, the dividend and the divisor. So as you can see, the dividend is an input std logic vector 3 down to 0, and the divisor is also an input std logic vector 3 down to 0. This means 4 bits. And also we have two 4-bit outputs, the quotient and the remainder. So this also std logic vector 3 down to 0 and std logic vector 3 down to 0, 4 bits. And the architecture is named behavioral. The inputs are first converted from the std logic vector to an unsigned type for arithmetic operations. So first we have the logic vector, and now is converted to an unsigned for the arithmetic operations. Within a process block, temporary values are used to perform the division. The temp reminder variable initially holds the value of the dividend, while the temp quotient is unutilized to 0. A counter is also employed to ensure the loop that performs successive subtractions does not run indefinitely. Then we have the process begins. By checking if the divisor is 0. If so, it sets both the quotient and the remainder to 0 to avoid division by 0 errors. In this part. The divisor is non-zero. The code enters to a loop where it repeatedly subtracts the divisor from the temp remainder and increments the temp quotient and updates the counter. The loop is constrained to a maximum of 16 iterations to prevent potential synthesis issues or infinite loops. So after completing the loop, the result is stored in temporary quotient and temporary remainder are assigned to the output ports, converting them back to std logic vector format. The design demonstrates a basic operation to implementing division using a successive subtraction in digital logic, handling both valid and invalid divisor cases. So now I'm gonna show you how it's working on the FPGA.
Welcome back. Now we are in the physical part. As you can see, I have programmed this FPGA with the divisor code. So if I enter in the inputs 4 divided by 2, it will be equal to 2. So I'm gonna show you. As you can see, I have this input with 4 and this with 2. So I have the length of 2, as you can see. Now I'm gonna be putting 8 divided by 2. So as you can see, we have 4. So now I'm gonna put 2 divided by 2. So we have a 1. So this divisor is working perfectly, as you can see.